Okay, so research methods. We're going to start with experimental methods. So in research methods, the first thing you need to be aware of are what we call the features of science. So these are things that should be present in something for it to be classified as a science. So there is a debate in psychology as to whether psychology is a science or not. And if something is a science, it should have all of these features. So it should have empirical methods, objectivity, replicability, falsifiability. It should have paradigms and a paradigm shift. So an empirical method is where it's a data driven method where you can use observations or testings to gain knowledge. So it's empirical, it's based on facts. The opposite of an empirical method is an anecdotal method, which is not based on facts and data. A science should be objective. So whatever measurements are made are not affected by the researcher. It should be replicable. So you should be able to replicate procedures, replicate experiments. It should be falsifiable. So this is the ability to be proven wrong. So if something is a science, you should be able to prove it wrong. And actually, that's what psychology does. You're not really proving that anything is correct. The point of psychology is to try to prove whether something is incorrect. And a science should have a paradigm. So it's a shared set of assumptions about something. So thinking that the world is round is a paradigm. A paradigm shift is where everyone's opinions on things change due to evidence. So, for example, a while ago, everyone thought the world was flat. And then science came along and proved that the world was round. So you would have a paradigm shift. So if psychology is a science, it should have these features. The first thing in terms of an experimental method is theory construction. So an empirical investigation can use a deductive method of construction. So a deductive method is where you observe a behavior, you create a theory based on that behavior, you create a hypothesis that you can test, you carry out research to test that hypothesis and evaluate your research, and then you alter your research if necessary and carry out more research. You then are able to either support or reject your theory. This is objective, it's controlled, and it's checkable. So this is what we call the deductive method. So this is an empirical way to conduct an investigation. You can also use an inductive method. You'll notice that formulation of a theory has moved in the inductive method. So in an inductive method, you observe a behavior, you create a hypothesis, you carry out a study and draw conclusions, but then you formulate a theory. So it's just two different ways to construct a theory. You've got the deductive method and you've got the inductive method. Sometimes deductive can be called top-down and inductive can be called bottom-up. In the inductive method, you're gathering lots of data to then formulate your theories and hypotheses. And in the deductive method, you're formulating your hypotheses, designing your experiment, and then collecting data. So they work in a different way. So inductive, bottom up, you gather your data and then create your theories. Deductive or top down, you create your theories and then gather your data. Now we're going to look at experimental methods. So the first type of experiment that you could use in psychology is a lab experiment. This is one that's carried out in a controlled environment. So it doesn't have to be an actual laboratory. A classroom can be a controlled environment where variables can be manipulated by the researcher and participants are aware that they're taking part in the study. They might not know what the study's about, but they know they're taking part in the study. So that's a lab experiment. A lab experiment is good because it has high internal validity and it's easy to replicate. However, it has low ecological validity or mundane realism. It doesn't really make sense outside of the confines of the setting it's in. And you can get demand characteristics where people are aware that they're taking part in a study. The next type of method is a field experiment. This is where an experiment takes place in a more natural or kind of ordinary environment or setting. The independent variable is still manipulated by the researcher, and the researcher will still measure the dependent variable. Participants are usually not aware that they take part in a field experiment. Good things about field experiments is they have high ecological validity and mundane realism, and there is a lack of demand characteristics. However, they have low internal validity because there's less control over extraneous, so external or confounding personality variables that might affect the dependent variable, and they are less easy to replicate due to the lack of control. Another type of experiment is a natural experiment. This is where you do not manipulate the IV directly, and the IV occurs naturally. So if you look at a breakfast club on someone's GCSE performance, that breakfast club and those GCSEs would happen anyway. The researcher doesn't directly manipulate them, they just go in and look at the effects. So that's what a natural experiment is. Positives of a natural experiment is you can conduct research where you cannot directly manipulate the IV for practical or ethical reasons, and you have a much higher ecological validity. However, there's a lack of cause and effect because you don't directly manipulate the IV. You cannot establish cause and effect and have this establish a causal relationship, and you cannot have random allocation of participants to groups because the IV will occur naturally. Another type of experiment is a quasi-experiment. This is where the IV hasn't varied by anyone, it just exists. So, for example, gender, looking at the difference between males and females in a certain situation, that would be a quasi-experiment. You don't go in and change the IV. An advantage of quasi-experiments is they allow comparisons between groups. They can be carried out in a lab. However, you can get low ecological validity because they're carried out in a lab, and again, you might have a lack of random allocation to groups. In terms of variables, an experiment will involve manipulating a variable, so that's the independent variable, the IV, to see the effect on another variable. So that would be the dependent variable, the DV, whilst trying to keep all other variables controlled. So the IV is the thing you manipulate, and the DV is the thing that you measure. Experiments look at cause and effect, which is how a change in IV will affect the DV. So the cause is the IV and the effect is the DV. So when we talk about causality and cause and effect, that's what we're talking about. In an exam, when you mention variables, they need to be operationalized, and what this means is put in a form that can be measured. So, for example, if the example above, if you say, if you're looking at the effect of revision on exam results, you can't just say revision, the amount of hours of revision or the amount of hours of reading. That's in a form that can be measured. That's operationalized. Other variables that we come across, extraneous variables. So these are anything else that can have an effect on the DV. These tend to be controlled by the experimenter. Time limit for tasks, content of words, they tend to be external things, so things in the environment. And then you've got confounding variables, which might ruin the results, the mood of participants, personalities, and so on. They tend to be internal things, the confounding variables. But the extraneous variables can be controlled by the experimenter. The confounding variables cannot be controlled by the experimenter. You will have an aim and some hypotheses in your research. The aim is the intention of the researcher, what the experimenter wants to happen, what they want to investigate, what they plan to look at. A hypothesis is a statement of what they are predicting to happen. A null hypothesis is a statement to say that there'll be no difference, that nothing will happen, it will be due to luck. And an experimental hypothesis is predicting what the effect will be or predicting what a difference will be. Hypotheses can be directional, so they predict a direction, or they can be non-directional. So you could say that there'd be a gender difference in driving abilities. That's a non-directional hypothesis. If you say that women are better drivers than men, that's a directional hypothesis. When we look at an experiment, we also look at reliability and validity. Reliability is about consistency. So we've got internal reliability, making sure that each participant is treated the same way. External reliability, making sure that every test can be repeated and you get the same results after each test. Test retest is a way to check reliability, where you use the same people and do the same test and see if you get the same results. Inter-observer or inter-rater reliability is where you use 2 or more observers to observe the same situation. You get them to observe this situation using the same criteria or the same categories. You then compare their observations and look for an agreement. You want to look for an 80% agreement, so whether they agree 80% of the time. Validity is correctness, whether something does what it's meant to. So internal validity is whether a test measures what it's meant to measure. If you turned up for a driving test and there was a car there, that's good internal validity. If you turned up for a driving test and there was a boat there instead, it won't necessarily test your driving abilities of a car, so that's internal validity. External validity, can we generalize an experiment beyond the setting in which it's initially done? So can we take an experiment that's done on college students and apply that to people of different age groups? Face validity is a way to check validity. Does something on the face of it look like it measures what it's meant to measure? Face validity. And then concurrent validity, does it match with the results of a similar test? So something that you'd expect the same results of, you can check to see whether it's correct on 2 tests. There is a separate PowerPoint on experimental designs. And then moving now on to sampling. So sampling methods are the ways that you get your participants for a study. The people that you want to do the study, the people that you want to investigate are called your target population. So if you're looking at research into students, the student body would be a target population. And there are different ways that you can sample your population. So you can do an opportunity sample. So that's people in a given place at a given time. So anyone that's available that wants to take part. A random sample is kind of names out a hat. Everyone has an equal chance of being selected. A stratified sample is one that represents the proportion of people in your target population. So for example, in your target population, if 30% are female and 70% are male, those would have to be the ratios you use in your sample. So that would be a stratified sample. A systematic sample is when every 7th person of the population is selected, so picking every 7th name off a list or picking every 3rd name off a list. And a volunteer sample or a self-selected sample is where people offer themselves to take part in a study, usually in response to some kind of advert. Research has to follow ethical guidelines in psychology, which you would need to know. So that's consent, confidentiality, deception, debriefing, the right to withdraw, protection from harm. There's also a code of conduct in terms of ethics and different types of consent, different ways to get people to agree to take part in a study. You also need to look at giving advice about colleagues that take part in ethics. And in terms of the exam, you might be asked to create a consent form, so a form in which people agree to take part in a study, or write a debrief form, so where you are telling people what the study was about and giving them access to information after they have taken part in a study.